Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing something really interesting when it comes to building .NET APIs and .NET application, which is going to be the mediated pattern and CQRS. We're going to be going through the theory of how we can actually implement it and why do we need it and how does it work. And then once we have covered the theory, we're going to go through implementation. We're going to be seeing step by step how we can actually implement the CQRS and mediator pattern. We're going to be seeing how we can actually upgrade our controller to take benefit of that. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Now with that said, grab your cup of coffee and let's get started. So before we get started in implementing CQRS and the mediator pattern inside our code, it's really good for us to understand why do we need them and how do they work. So in this example right here, what do I have? I have different services. So let me try to name them. So for example, this can be the service one here. This could be our mediator service, or sorry, this could be our AppDB context. Another one could be, for example, here our logger. We can have a third-party service, for example. We can have our unit of work. We can have here, for example, another third party and another third party, for example. So as we can see here that all of these services are directly interconnected with each other. So what means here, like service 1 needs to know about service 5 and how does it communicate with, that it does need to know how everything is connected. So we need to make sure that it has the right dependency injection, so on and so forth. Similar to service 2 when it comes to service 4, 5 and 6, service 3, service 4, 5, 6, etc, etc. So all of these services will basically need to understand everything about all of the other services. They need to know how do they communicate with, what do they need in order for them to initialize them, what are their dependencies, and all of this information. So every single service here will need to know about all of the other different services. So for example, service 1, you need to know about 3 services, service 2, 3 services, etc, etc. So as we can see here, these services are directly coupled together. There are a lot of interconnectivity and direct tightly coupling together. And for example, for a very small project, that could not be a problem. But as soon as we start scaling and adding more functionality, adding more services, having all of these tightly coupled together is going to start creating a lot of issues when it comes to testing. Upgradability will be complicated. Every single service will need to basically, if we add, for example, here a service 7, and we want to utilize it within service 2 and 3. So this means that we need to reintroduce how these services work. So basically, what does this mean? So we need to update all of those interfaces within those services so they will be able to communicate with this service, and then thus we're going to create another layer of interdependencies between them, and it's going to create a lot of different problems when it comes to handling all of these interlocks and these dependencies between these services. And as we can see, this model here is really not really very scalable because it's going to create a lot of very tight coupling, and handling these tight couplings can become quite complicated very quickly. So this is where the mediator pattern comes into place. So basically a mediator pattern takes and remove all of this complexity. So what do we have here is a very simple approach. So instead of service 1 knowing how to communicate with service 6, service 5, service 4, etc, etc, all that service 1 needs to do is just tell the mediator, I have this request and I want to communicate with service 6, and this is the information that I want to send. The mediator will take the request, figure out what service 6 needs in order for it to actually work, and then it will propagate the requests. If service 2 wants to communicate with service 4, again, similar pattern there. The request will go from service 2 to service to the mediator. It will tell it what does it need. Then the mediator's responsibility is to actually figure out what are the requirements to communicate with service 4, what are the dependencies, all of that, and then the mediator will provide it, and so on and so forth. So here we can see is we went from this spider web of interconnectivity and interlocking between all of these different services and the tight coupling into something which is completely distributed and basically less complex, because we have removed all of the reliabilities that every single service needs to know everything about all of the other services. And what we did is we have basically made the mediator as the main pipeline in order for us to actually handle the requests between those different services. The mediator here is playing a key role in actually propagating the requests between one service to another. And for example, if service 2 wants to communicate with service 6, all it does need to do is just send the mediator a request and do that. So if we introduce, for example, a service 7, we don't really have to worry about making sure all of the other services are aware of service 7 requirements and how do they work. All we need to do is just to make sure that the mediator is aware of it, and that's it. We can utilize any service from there in order for us to communicate with service 7, and so on and so forth. And we can see here the power that the mediator platform provide, and why do we need it in a service-based approach, because the level of complexity that non-mediator will provide us just can be drastically big. So this is a very high level overview of the mediator. We're gonna go into a very deep and low level implementation so we can understand how we can implement it within our applications. But before we do that, let us now understand the types of the requests that the mediator provide. So we have two types of requests that the mediator provide. There's the notification and there's the request response. The notification part we're not going to be delving into right now. If you're interested in the notification part, please let me know and I will create a different video about it. In today's video, we're going to be focusing on the request response. And what does this mean? So a request response means that whenever a single request comes from one service to another, there's some kind of a handler that the mediator have in order for it to process that response. So what does this mean? If we take a look at this one here, if we have service 1 and it's what service 1 wants to communicate with service 6. So the request will go from service 1. Let's just make it green so we know what is the request coming here. So service 1 wants to communicate with service 6. So service 1 will send the request to service 6, to the mediator. The mediator then what it needs to do, it needs to find something called the handler. We're going to explain what the handler is later on, but it's basically a way where the mediator actually recognizes the dependencies for service 6. So I'm just going to call a handler. So the mediator will find the handler that's going to be using. Once it finds the handler for service 6, then it's going to actually allow the communication with service 6. So it's going to be something around those lines. So we're going to put 1. So this is the initiator. So this is going to be the first part. And then it's going to go to the mediator. The mediator is going to find the handler. And once the handler has been found, we can actually trigger service 6 and get the response back. And then lastly, so 1, 2, 3, 4, and lastly we're gonna get back the response. So here again, lastly we're gonna get back the response. So because it's gonna go all the way back through this. So this is the request response. So it's gonna go from the service to the mediator, and here we can think about the handler is just a way where the mediator is basically a service that the mediator use in order for it to figure out how to communicate with service 6. And here, as we can see again, within any request, once the request comes in, it will find the handler for it. So the mediator will find its handler and then it will send back the response. Again, similar implementation. So here, for example, for every single service, we're going to have its own handler. So request 1 will go to the mediator. It will find the handler for that service and then get back the response. Similarly, request 2, etc., etc. So again, we're removing all of the interdependencies that we need. If you don't really understand the handler right now, we're going to explain it much more in details in the code, but this is the high-level overview. A handler is basically a way where the mediator pattern rely on in order for it to actually understand how it utilizes service 6 in order for it to find the data that it needs. So Now that I've understood the high level of a mediator and its implementation, it's really important for us to actually understand right now CQRS, because you can work with Mediator by itself, but basically also it will be really good to use Mediator with the CQRS pattern, and we can see how those two work together, and in order for us to have the better approach. So if we go back here, let us understand what does the word CQRS means. And CQRS is a pattern which stands for Command Query Responsibility Segregation. And this can mean a lot of things. If you're not really familiar with it, and it can seem a bit complicated. But basically what we can think about it in a way that we are separating the commands and the querying into different responsibilities. As simple as that. We are basically trying to remove the complexity of handling any commands and any querying to different responsibilities. The commands here is going to cover a wide range of items which we're going to be delving into, and the querying here is just basically thinking about it in a way where we can actually asking the service in order for us to do something rather than trying to update certain types of information. So I know that doesn't make a lot of sense, but let us see this in this example. So in this example here, we can see that we have a client, and this client is doing some API calls. The API is basically responsible to process that request, send it to the database. The database will send back the information. Then the database, the API will process this data and send it back to the client. So this is a fairly straightforward API implementation where we can actually see here the full pattern, or basically the full life cycle of a request. So without CQRS, can delve into these types of operations. So every single endpoint within our API that we have seen previously is going to come through a controller. And within that controller, we're going to have the main CRUD operation. We're going to have a create, read, update, delete. We might have a put, we might have a patch, we might have the head, so on and so forth. So we can have a lot of different request types when it comes to our controller. But basically, when this request comes in from our client, it's going to go to the main API. It's going to go to the domain first, and then the domain is going to be responsible for actually sending that request to our data access layer. Then through our data access layer, it's going to go to our database. Then it's going to go propagate back from our database. We're going to get the response through the data access layer, to the domain, and back to the client. So here we can see basically all of these types of requests that we are actually coming in is handled by the same domain. And this same domain connects to the same data access layer that actually connects to the database. And here we might actually start seeing the problem. Although this implementation is fairly common for a small to a bit medium implementation, but this can create a lot of different problems the more that we want to scale out our application and have better separation of concern, better testability, so on and so forth. Why? Because let's say, for example, I'm running some kind of a news site, and let's try to do it here. So I'm gonna create some spaces here on the side, and let's explain it. So let's say I'm trying to create a news site, and within this news site I have, let's say, 15 journalists, and these 15 journalists are responsible to doing the 4 CRUD operations that we currently saw. So let's just copy it from the other screen. So these 4 journalists are basically only doing these: creating, updating, reading, and deleting news stories, which is fair enough. So these journalists have the capabilities of doing all of these CRUD operation on this news site, which is fair. But these 15 journalists are only actually doing all of this implementation. Now let's think about the public itself. So the public itself, as I'm sure like everyone here, in the morning they check the news. It can go from one single individual to hundreds of thousands of people actually checking the news. It depends on how popular your site is, but let's say it's a very popular site. And basically all of these people will not have the capabilities of actually updating, deleting, and creating the news. So for the 15 journalists, they're gonna have all of these capabilities needed for them. And within that approach that we currently had, which means they are gonna have access to the domain, the data layer, and the database. But for the other people, so which is going to be the news readers here, for this news readers, they will not be able to have access to the create, or they will not have access to the update or the delete. So all the newsreader will have access to is simply the read, while on the other hand, the journalist will have access to the create, they will have access to the read as well, they will have access to the update, and they will have access to the delete. So that means, and let's make this like this so we know exactly which is what. So let's make this a different color. So this one, let's make this as purple. Okay. So now we can see where the problems lies in, because right now we have all of these connections coming into our applications, and all of these connections are basically relying in the same implementation on a single domain, and then on the single data access layer, and then connecting to the database. But for example, for our news reader, we don't really need to do we don't really need to have the update and delete and create available for them, because they don't need it. They don't have access to do it. Only the journalists who actually create the news will have actually ability to create and update and delete the news. And this is going to be the main thing here. We need a way where we can actually try to segregate these requests into the read, which is only going to be utilizing querying the database for information, getting it, rather than trying to do any types of command on the database and trying to update the information, creating it and deleting it, so on and so forth. So this is where the CQRS pattern come into place. Now let's see how this model will transform with CQRS. Within a CQRS, what we're doing here is we are actually separating the main CRUD operation. What we're doing is we are actually breaking down the CRUD operation into two main sections. With the querying, which is going to be the read command here, because basically we are querying the data for information. So I can say this is going to be the query part. The querying part, which is going to be this one. Let's just make it like this. And I think it's here. Yes. So this is going to be the query part. And we're going to have the command part, which is going to run all the way from here till here. And the command here is going to be basically allow us to execute some kind of command on the database, like basically create, updating, and delete. So we can see here that we have those different implementation. We have two different layers that the application will need to be able to process, and then that will go into our data access layer. We can see we have two different data access layer. One, the data access layer, which is completely responsible for querying, another data access layer which is only responsible for the commands, and they're gonna speak with the database. Now this implementation seems to be almost identical, because all of when it comes to the communication of the database, because all of them goes to the same database. A better approach to handle this is have different connection strings. So we're going to have a unique connection string here for the data access layer, for the querying, and another connection string for the command. And this will allow us to have a full separation of the processes that we actually need in order for us to actually execute. So the read request is less taxing on our database, but on the large quantity we need to have its own unique implementation, or basically separate servers who are handling all of these read requests, because they're going to be quadruple the size. So rather than 15, we can have hundreds, millions of people who's using the site to get the news. On the other hand, for the create, update, and delete, we're going to have a few like journalists, like 15, 20, 50, even 100 or 1,000. It's going to be less than the millions that we're going to be seeing for the readers. So it makes sense to have different connection strings, to have different way to connect to the database based on the types of action that we're currently doing. And this is where CQRS come into place. A segregation of these two requests, one for the querying, which is actually only reading the data, and the command, which is going to be create, updating, and delete. And this pattern here that we currently see is a way where we can actually if we want to unit test the querying by itself or the commands by itself, we can do that. If we want to do stress testing, it will allow us to do that. Chaos testing, it will allow us to do that. I'm not saying that those the other ones will not be able to handle all of that, but these one will be able to actually give us much more of a right approach, or basically right information about what's going on inside our services when it comes to handling heavy load, because we are actually able to see what is the main weak point, for example, inside our queries that we're trying to get out of the database, or inside our commands to have better visibility on whatever is going on inside there. So this is a very high level overview again of CQRS and why do we want to need it. So as we can see here, the difference is we are actually separating the main CRUD operation from between create, read, update, and delete to actually read, and this is going to be the main query, and create, update, delete as the different items that we are going to be handling. So this is the full level overview. So now for the implementation, we're going to be utilizing the application that I have built in the last video. It's going to be simply a CRUD API that I have created. If you're interested in following how I created that, I will link the video here and in the description down below, and we can start from there. But this should work with any API that you currently have as well. And all I'm gonna do here is just run it for now. So this is the application that we created previously. As you can see here, that we have a simple controller which contain drivers information, and then we have the achievements, and we have basically a very simple SQLite database that we're utilizing. As well here we have our program.cs, and we have separated the data service and the entity into different projects. Again, more details about this in the previous video, so please, if you're interested, feel free to watch it so you're able to follow on exactly, but this will work with any types of application or APIs that you currently have as well. So let us run this and see what do we get. Now this is running. We can see here that these are the different endpoints. So for a driver, we have a full CRUD operation where we're actually getting the driver's information, delete, post, put, and get all drivers. So let's try to execute this, try it out, execute. And here we have only one driver currently, which is Sir Lewis. And if we take the driver ID and we try to see the achievements, so we can actually post an achievement, update it, and get it. So if we try to get an achievement based on the driver ID, we're able to get the achievements here. Okay, perfect. So now that we are 100% sure that our application is currently working as we need to, let's go back to Rider and see how we can actually start implementing it. Let's take a look at our terminal, because what we want to do is we want to start actually creating and adding some packages. And the first package that we need to add is going to be our Mediator package, and it's going to be .NET add package Mediator. And we can see it has been installed successfully, and to verify that it has been installed, we can check our CS plots here. And if we go down here, we can see that the Mediator pattern has been installed. And something that I want to note, that currently the Mediator pattern is on version 12.1.1. So any version of the Mediator pattern after 12, this is the only package you need. Before version 12, there was a different package for dependency injection that you needed to also install. This is not the case anymore within version 12, but just for your awareness, if you're using version anything before version 12, make sure you install the other package. And if we go back to my web browser, let's try to find it. So Google NuGet package Mediator. So this is the one that we have currently installed, but if you go back, this is the other one, which as you can see has been deprecated, but this will work with anything before version 12. So make sure that if you have anything before version 12, make sure you install this one as well, so you are able to actually utilize dependency injection with it. So now that we have that has been said, let us go to our program.cs and start updating it in order for it to utilize the Mediator. So what I want to do here is, again, before we build the app, what I want to do is I want to add builder.services. And here all I'm going to be doing is I'm going to injecting the Mediator package. So add Mediator. And now what I wanted to do is I want Mediator to be able to scan my entire dependencies and to actually able to figure out the DLLs that currently exist there in order for it to be actually able to scan and view the handlers that it needs to and try to identify the requests, so on and so forth. So to do that, I'm gonna utilize my configurations, and I'm gonna say configurations.register service from assembly, and then here I'm just gonna put type of and program, and let's fix this. So there's a lot of different brackets that we don't need, so let's remove one, and let's remove this, so we have two. Yep. And then all I'm gonna put here is .assembly, and then I'm gonna close it. So this one should be here. We need to close this one, and then this. We don't need this one. Let's remove it. Actually, we do. Okay, perfect. So now it's actually working, and this is the line we're going to be needing. So here we're injecting the mediator to our DI. Perfect. Again, all we're doing here is just telling the mediator to scan all of the assemblies that the program.cs, because it's going to be the main entry point in order for it to be able to utilize it. So what we want to do here is we want to implement the mediator to our driver's controller. And within our driver's controller, if we take a look here, let me just make this smaller. If we take a look, we have the get, which is going to be the first one. And then we have the post. And then we have a put. We have another get. Let's put the get next to each other so it's easier for us to do this separation. And again, here we have the delete. And where is the post? Oops, that's the post. Okay, so we have post, and we have the put, delete, and together. Okay, perfect. So these controller endpoints are basically the simple CRUD operation that we have seen. And as you can see through all of this, for every single item inside our controller, we have a lot of logic going on. So for get all drivers, it's quite simple. We're basically calling the unit of work to get all the drivers, and then we're returning the response, which is fair enough. For the drivers that get a bit more complicated, where we're actually validating the input request, and then basically from there we are mapping it from a DTO to the database entity, and then we are adding it into our application, into our database, and then we're saving it, and then we're returning the result. So we can see a lot of items is going on here in order for us to get this response. So what we want to do right now is we're going to start implementing the mediator work step by step, first of all on the get. And we're gonna start separating the logic here and have the mediator to be able to handle all of the queries which is coming in part of the CQRS pattern, and the mediator will be able to handle all of that. So let's see how we can implement this. So the first thing that I want to do here is inside my root application, I'm just gonna add a new directory, and I'm gonna call this queries. And inside my queries, I'm going to add a new class, and this class is going to be called get all drivers query. And yes, I'm going to add it. So the idea behind this here is I want to have a directory where it's going to be handling all of the queries that the application might handle. So currently it's going to be for the driver. This can be organized in a bit more sophisticated way, but for simplicity's sake, in order for us to make sure that everything is simple as a first implementation for CQRS, we're going with this way. So once I do that, what I want to do here is I want to inherit the I request from mediator, and basically the I request here, it's gonna tell the mediator that it's gonna have a request coming in that it needs to actually figure out the handler for. And basically, once I'm creating this query, if we remember from the design, let's go back to the design. If we remember here, basically, every single request that a service will make is being considered a request. So basically what I'm identifying that this is gonna be a mediator request, so I need to inherit from that request's request class that the mediator will provide. And basically what I want to do here is I want to specify the type of request, and in this case it's gonna be the get all drivers query, and I want to specify the type of response. And if we go back to the drivers controller, and for the get all drivers, we can see the type of response is an enumerable of driver, which is going to be this one here. So let's get enumerable driver response, and this is going to be my response type. And basically right now what I did here is I created the request for the mediator, so this is the first part, and I specified the type of response, but I did not work on the handler yet. So that's something that I have to do next. But for now what I did is I just identified that request. So let's put this here. For this request I have defined first of all the type for it, so let's just make it smaller. So type, we said it's going to be a query, because basically I called all driver queries. That's the only way I told it. It's not related on the convention. It's basically a way, because it has a very simple implementation here. I just did the I request for it, and then we specified the response type. And here's going to be a list, or enumerable. Let's make it list because actually let's put enumerable to be more accurate. Let's make this a bit bigger. Perfect. So now this is what happens when I created the request. So first of all, I identified this, and let's add this here. Okay, perfect. Okay. So now that I have created my request, I was able to identify it. This request by itself is not gonna do much because it needs other parts of the mediator in order for it to work. So let's see how we can actually build it. I'm gonna just mark this as green now here as the request. Now what you can see here, after the request, I need to create a handler. So now within the handler, I need a way where we can actually identify which is the type of query that I have and actually process it. So inside my root controller here, I'm just going to create a new directory, and I'm going to call this handlers. And inside my handlers here, I'm going to create a new class, and I'm going to call this class get all drivers handler. Perfect. And basically this get all drivers query is going to have its handler, which is going to be here, and it's going to be called the get all drivers handler. But having this query by itself, it's not going to be enough. What I need to do is I need to inherit different items from the mediator package in order for it to actually recognize that this query, this handler belongs to this query. So let's see how we can do that. So here what I need to do is I need to inherit from the I request handler. I need to specify first of all what type of request that this handler will handle, and I'm gonna put the get all driver queries, and then I need to specify again the return type. So if we go here to all the driver queries, we can see that the return type here is gonna be the enumerable. So I'm just gonna put this here, and I'm gonna have to fix those references. Perfect. And now it's complaining because we have not implemented it. So let's implement the required members. And as you can see here, the only members that we have is a handle function, which is going to be allowing us to handle that where we can input the logic that we need in order for us to handle this request. So again, what we did here first is we created the query, and basically we said that we're going to have a query type, and it's going to return a enumerable, and we specified it as a request coming in. And then what we did inside the handlers is we just inherited, or basically the I request handler, and then we specified the query, and then we specified the return type. So currently here inside the request, so basically first of all we specified the query. So let's just copy this, and here we put query, and then we have specified the response. Just to make this more accurate here, we did not specify a type. It's just based on the naming convention. So all we did for the request is just specified the response. On the other hand, for the handler, we have specified the query and we have specified the response. So this is, I'm gonna make it in different colors. So now that we have specified the request, now we have created the handler. What we want to do right now is we start implementing it. So an easy way for it to implement it, let's take a look at what are we doing here inside the get all drivers controller. So inside the get all drivers controller, we are relying on the unit of work service to actually call the database, and basically we're relying on the auto mapper in order for us to map the response. So we need these two. So in order for us to utilize them, what I want to do is I want to go to my base controller and I'm gonna just copy these two. Actually, let's copy all of it and we can update it. And let's go to the drivers handler. And basically what I want to do is I want to inject this here. So now basically I'm injecting those two services inside my handler. So the handler will have access to the unit of work and auto mapper. And inside my drivers controller, I'm just going to remove all of this logic that currently exists here. Actually, yeah, let's just separate it so it make it easier for us. So I'm going to put var drivers result. Again, this is, we can call it whatever we want. And I'm just gonna make this like this. And I'm gonna return the driver's result. And now what I want to do is I want to take these and put them inside my handler. So if I go back here to the handler and I can put them here. So now as you can see that this is taking it. So I'm just gonna put as an async so it will actually recognize it. And what I want to do is I'm just gonna return the results from here. Oops, so I'm gonna put return. So now what I'm doing is, let's make this private and private. Okay, so what I'm doing here is I'm just handling the request. I'm putting the logic of the get all drivers requests inside my handler. So whenever a request comes in and the handler needs to identify how it works, we're actually adding the logic that we need to in order for it to recognize. And I think what you can see here is why do we want to use that? Because you can see the logic of executing the request is not directly linked to the controller anymore. We have a handler who's responsible to identify all of the dependency which is needed, which is in this case going to be the unit of work and the auto mapper. And we're not relying on the controller to do this heavy lifting. We're delegating this work to the handler and the handler will be able to do this. And as you can imagine, this will make it much more easier to do unit testing. It will make it much more easier in order for us to scale this out. And it's going to be basically a better approach to handle within our APIs. So now let's see how we can complete the full circle. So now that we have done this, we have added the query, we have added the response type, and we have added all of the logic that's needed. So the logic for the query here. So all of this has been completed. Now what I need to do is I need a way from inside my drivers controller where I can actually rely on the mediator to actually pick up this request. And this is going to be straightforward to implement. So let's see how we can do that. So the first thing that I need to do is I need to inject a new, I need to utilize the mediator library. So it's going to be private read only iMediator. I'm going to call it _mediator. And then I'm going to inject it here. So I'm going to use rider to initialize it for me. Perfect. And then once I have done that, I'm going to go to my action here. And inside my action, what I want to do is, first of all, I want to define a query. So var query equal new get all drivers queries. So basically what I'm doing here is I'm specifying the query that I have for this endpoint. So this is going to be the query that this endpoint will handle. And then what I'm doing here is I'm going to put var result equal await underscore mediator dot send query. And that's it. And then all I'm going to do here, instead of driver result, I'm going to return the result. So what happened here? So I specified the query that I have, which is in this case, it's gonna be as simple as telling it it's gonna be a incoming request, and it's gonna return time is gonna be of I driver response. And that's all I did within my controller, because what Mediator does here, it will actually take this query, it will actually send it, and it means that it will process it. And what the Mediator will do is gonna do a mapping of the entire handlers to see which request it will map into. So if you noticed, we did not specify the direct handler for this query, but because inside my handler folder I have specified that this handler that I created belongs to this query, the Mediator is smart enough to actually recognize that this is the handler for this query, and it will automatically execute it for me. So I'm not gonna be responsible to specify which handler to which query. This is the Mediator stuff that was gonna be doing for us in the background, and it's gonna do all of this mapping for us. So what we have done here is we have specified the request, we have specified the handler, and then finally we got the response. So again, it might seem a bit like magic of how does it know about the handler and so on and so forth, but all of this is happening in the background, and the Mediator is actually doing all of this work for us. So here what I want to do is I want to run my application and see this in action to see if I'm actually able to get the response. So now that it's running, I'm gonna go back to my web browser, and I'm just gonna refresh this and get all drivers. I'm just gonna click try it out and execute. And as you can see here, we got all of the responses back. And what I want to do right now is just gonna put a breaking point to see what's happening. So again, I'm gonna execute this again, and we can see here we hit the breaking point. And we can see here from the query, we're basically just calling the got all driver. It does not contain anything. All this is basically inheriting the I request from the Mediator pattern. And then once I click on send, and I'm in the send, I'm just gonna put in breaking point here, so we can see that how the Mediator is automatically using this. So if I just continue running it, so I'm gonna put resume, and we can see that the breaking point hit the right handler that we have, and basically it was able to figure out that this is going to be returning the list of drivers, and currently I have one, and then it does the proper auto mapping for it, and then it returns back the response. So all of this, let's see the response here. So all of this is basically handled by the Mediator, and we can see here how, if we go back to our drivers controller, how it's much more less busy. Our endpoint is going to be only 3 lines, and within this 3 lines we are able actually to execute everything. So now what we're going to be doing is we're going to start implementing this for the get driver. As you can see, this is a bit different because here we can see we have a driver ID that we want to pass. So we're going to see how we can implement that. But once we do that, we can see that how the logic that we are actually implementing is shifting from our from our controller to our handler. And here we can see this good separation of concerns that we need to actually follow. So to implement the get driver query, I'm going to create a new class, and I'm going to call it get driver query. Again, I have to inject from the I request, and I'm going to specify the return type. So if I go here, we can see the return type is get driver response, and I'm going to import the reference. And this is basically the first step, but this is not enough, because if we take a look at the controller, we can see here that I have driver ID, and what I need is the query here actually to recognize that there's going to be an ID that it needs to actually process in order for it to work. And let's see how we can do that. So first of all, I'm gonna create a private GUID driver ID, and I'm gonna make it as a get, and then I'm gonna put a constructor, and then I'm gonna initialize it through the constructor. And basically right now what I have here is the driver, not the driver. So now that I have this, now basically my query right now is able to recognize that there is an parameters that it needs to take into consideration when I'm executing. So once this has been done, now I need to go back to my handlers and I need to create a new handler. I'm gonna call it the get driver handler. And again, we're gonna follow the same structure that we had before. I'm gonna inherit from the iRequest handler, specify the query and specify the response type. So I'm gonna go here, I'm gonna put iRequest handler, and the request is gonna be the get driver query, and the response type is gonna be, I think, the get driver response. Yep. And again, it's gonna require us to implement the missing member, which is the handle. Let's make this async from now. And just for simplicity's sake, I'm just gonna copy these a unit of work and IMapper from here and just put them here and update the constructor name. Okay, perfect. And now what I need to do is I want to implement this handle function here. So if I go to my driver's controller, or for this get all driver, what I'm going to do is I'm going to take this and I'm going to put it inside my handler. So first of all, we can see here that we are not able to find the driver's ID, which is fair enough. How can we access it? It's pretty straightforward. Because I have my request, I can directly tap into the... Why it's not showing? Let's see. Driver ID. Let's go to the query. Oh, it needs to be public. Okay, perfect. So now that I have access to my driver ID, so in case the driver is null, I'm gonna return null. Else what I'm doing all of this and I'm gonna be returning the result. Let us optimize it. So instead of having this, I can just put return, remove this, and perfect. So here basically what we have is we're getting that driver ID from the database. If it is null, we're returning null, else we're just returning the map function. Perfect. So now how can I use that? Pretty straightforward. Again, I need to specify my query equal new get driver query, and we need to pass the driver ID, because if we take a look at it, it's expecting a driver ID. And again, var result equal await underscore mediator dot send, and here I'm going to be sending my query, and I'm going to say if result equal null, I'm going to return a not found, else I'm returning the result. Again, this I can, yep, something like this. So now let's try this. If I go back to my web browser and let's get driver by ID. So first of all, I'm gonna get the IDs of the driver. Let me remove this breaking point. Perfect, we got Lewis's ID. Let's take that. And if I go here to get driver by ID, try it out. Description. And we can see here we got the driver ID. Perfect. And if we want to put a breaking point again inside my driver handler, just to make sure it's actually being picked up, execute, and we can see it's actually directly being picked up and the ID is being passed correctly. Okay, perfect. So now that we have handled the two query stuff, which is going to be the reading from the database, now let's see how we can actually implement the command, which is going to be either creating, updating, or deleting. And as you can see here, this separation of concern that we currently have is really powerful, because all of the logic is being shifted out of the controller, and the controller, if we take a look at it, is actually becoming pretty simple. All we're doing is specifying for every single one of them is the actual query, and the mediator is taking responsibility to execute the rest of the logic, which is pretty cool. So now what we're going to be doing is we're going to check the post and how we can actually convert this into the mediator pattern. So first of all, I'm going to stop my application. So inside my root directory, I'm going to create a directory. I'm going to call it commands. And inside this commands, similar to what we have for the queries, I'm going to create a new class, and this class I'm going to call it create driver info request, because we want to add a driver. So basically what we're doing right now is we're gonna convert the post for adding a driver into a command. And again, similar to what we have done before, I need to specify it's gonna be I request type, and I need to specify the return type. So this one here, the return type, it will not have any, but what actually we're expecting here is the the return type here is going to be the result, which is going to be of type get driver response. So let's do this here. Let's update it. So here I'm going to put get driver response. And then something else we need to take into consideration, that here we're not taking a simple query string. What we're doing is we're actually having an object that we want to send. And this is going to be pretty straightforward, similar to the GUID. So what we want to do here is we want to make it a public. Let's copy this request. And I'm going to call it request, just to driver request, just to make it simple. And it's going to be get. Let's fix this reference. And here I'm just going to specify my constructor, and I'm going to tell it to initialize it through the constructor. Okay, perfect. So now, similar to what we have done previously for my get driver with the, not this one, sorry, with the query, we specified the query and we initialize it. Similarly, we have done here for the command. We specified this object that we have, and we have initialized it. So again, for this, what I want to do, I want to now add the handler for it, and I'm going to call it this get driver info handler. Again, similar to what we have done previously, I'm going to inherit the I request handler. It's going to ask me what is the request type. I'm going to put the create driver info request, and I'm going to specify the return type. It's going to similar get driver response. Again, let's fix this. It's going to ask me to implement the handle method. Perfect. I'm going to make this async. Again, similar to what we have done here, I'm just going to copy these just to make it easier for me. Copy. And let's go to get driver info. Let's put them here. Update the constructor name. And let's import them. And now let's go back to my driver's controller. Let me take all of this logic that currently exists. And let me put it inside my driver handler. Let's remove this. And here I'm going to update this to driver. And here it's going to be, instead of driver, it's going to be request.driver request. And what I want to do here is, once I map it, first of all, from the driver request DTO to the database entity, I want to now revert it back. So we can do the similar thing to what we have done here. So let's take this. We're going to put var result equal. Actually, we're going to put var driver result. Oops, equal. And instead of driver here, we're just going to have, I'm going to call this driver instead of result. So we'll make it more consistent. And this can be a result again. And what we need to do is we need to return it. So there is no benefit of calling it result. We're just going to return it. Okay, perfect. So now that we have this in place, now let's go to the driver's controllers, and here it's gonna be pretty straightforward. I'm gonna put var command, because we're doing a command now. I'm gonna put a new create driver info requests, and here is expecting the driver. Again, I have to create a var result for my query. It's gonna be equal await underscore mediator dot send, and it's gonna send the command. So if we take a look at this one here, we need to update this from ID to driver ID, and that should be it. So now if I run this, and I go back to my web browser, and let me refresh this, and let's try add the new driver. So I'm gonna try to post a new driver, try it out. So first name, put George, Russell, driver is 63, year, I don't know, let's put 1999, skip it like this, execute, and now we can see George has been added. We got the 201. If I get all drivers, we're now actually able to get Lewis and George, Russell, not Russell. Anyways, now we can see it's all working as it should be. And basically within this, we are able to see how we are able to have both the request and the query from within our API endpoints, our API controllers, where we have actually able to handle a query, handling a command, and how these two work together. Now what we're going to do is we're going to continue implementing the put and the delete to actually fall within the same pattern, and then we can clean up our controller even more and make it much more simpler. So let's see how we can do that. So now let us update the update driver. So first thing, inside my command, I'm going to create a new class, and this I'm going to call it update driver info request. And here all I'm gonna do, I'm gonna inherit the I request, and I'm just gonna make sure the return type is Boolean because it's an update. I'm not gonna return anything. And if we take a look at the driver's controller here, we are expecting the update driver request as a parameter. So let's make it as a public, and let's make it as a get, and let's make this as a capital D here, and let's fix this reference. And then inside my constructor, I'm gonna just initialize this. Pretty straightforward, perfect. And let us, inside my handler here, I'm gonna add the handler for it. So I'm gonna say update driver info handler. And it's gonna be also pretty straightforward. I'm gonna put the I request handler. It's gonna process the update driver info request, and it's going to return a boolean, and now it's going to complain that I did not implement the handle method. We have done this already here, and now all I'm going to do is just I'm going to copy this implementation so I don't have to really copy it, retype it all, and I'm going to update the constructor name and fix this references. Perfect. And now lastly, if I go back to my controller, I'm just gonna copy the logic that I currently have here, and I'm gonna add it to the update handler. And I'm gonna first of all make sure that I return true. And here, instead of having a driver, I have to utilize the request to the driver, and I'm gonna fix this reference. Perfect. So now that my update driver info handler is completed, I can update this. It's going to be pretty straightforward, similar to what we have done with the create. So I need to create a command, var command equal new update driver request. It's going to request the driver as a parameter. Update driver info request. yeah, info request. Perfect. And then I have my result equal await underscore mediator dot send, and I'm gonna send the command that I have, and I'm gonna say if result, I mean if it's true, I'm gonna return no content. Let's make it as a single line. So I'm gonna put result, no content, or bad request. So that's gonna be for the update. Now let's do the same thing for the delete. So for the delete, we're taking a driver ID. So let's create this command. I'm gonna create the delete driver info request. And basically here it's gonna be similar I request, and it's gonna return a boolean. And because it is expecting an ID, driver ID, so let's take this and let's take it to the delete, and let's make it public, and let's make it as a get. Let's update this as capital D. Oops. And what I want to do here as well is I want to initialize it. Perfect. Now that this is in place, now all I need to do is go to my handler, create a handler for it, and this is gonna be straightforward. So I'm gonna put a delete driver info handler. Perfect. Again, pretty straightforward. It's gonna be of type I request handler. It's gonna take the update driver information request, and it's gonna return a boolean. It's gonna complain, why didn't I implement the handle? I'm gonna make it as async, copy these, put them here, fix the constructor, fix the unit of work. Perfect. And then once I have done that, what I can do is I need to go back to my drivers controller. Let's take all of that. Inside my delete, I'm gonna put it here. So this is gonna be request.driverID update. Oops, so this is wrong. It's not the update, it's the delete driver info request. And this is gonna be the delete driver info request. So here all we're gonna have is a driver ID. And if it's empty, I'm gonna return false. And here we're gonna have to put the request, the driver ID. And if everything goes into as planned, I'm gonna put the return true. And then inside my controller, I need to update it. So it's gonna be pretty straightforward. Var command equal new delete driver info request. We're gonna pass a driver ID. And lastly, we're gonna put var result equal await underscore mediator dot send request, and we're gonna send the command, and we're gonna say similar to this one. Let's just copy it. Perfect. And as you can see here, that all of the dependencies that we were relying on before is gone. Our controller is much more simpler. So right now, if I update my base controller, because we currently need it in the other one, I'm not gonna remove them. But in fact, I don't really need the unit of work of or IMapper inside of here at all. So what I can do as well to make it easier, I'm just gonna take my initializations here, and I'm gonna put it inside my base. I'm gonna fix this reference, and I'm gonna implement this here. And inside my achievements, I'm gonna do the same thing. I'm just gonna implement it, so I can just take it as it is from here, and I'm gonna put it inside my achievements. And let's fix this reference, and I'm gonna make this here as a mediator. So here as well, it's expecting us to update it, so let's do that. And we don't need to initialize this here. Now let's see inside my base controller. I need to make it as protected. And that should be it. So now if I run everything, so let's run this. If I go back to my web browser, as we can see here that, let's try with the get all, execute. Perfect. And let's try to do the get for a single driver. So let's take the ID for George. We are able to get it. Perfect. Now if I do the delete, let's see if that will work. Again, driver ID. We got a 204, no content. Now if I get all drivers again, I should only see a Lewis. Perfect. Okay, so now that we have implemented the CQRS pattern inside our application, we are actually able to see how everything fits together. We were able to see how we can actually separate all of the logic from inside our controller into different commands and queries and handlers. We were able to see how Mediator was able to facilitate this for us, to have a proper separation of concerns. If we wanted to have a full different query string for our GET request. If you're interested in implementing this, please let me know in the comments down below, and we'll make sure to have a video to cover this. But in general, we were able to see how Mediator played a crucial role here, and basically to have this separation of concerns, and how we were able to implement the CQRS pattern in order for us to have a better testability, usability of all of our API. If you'd like this video, please like, share, and subscribe. It will really help the channel as well. If you'd like to support me, please consider supporting me on Patreon or buying me a coffee. With that said, have a great day, and thank you very much for watching. Any questions that you might have, please make sure you put them in the comments down below. Have a great day.